This lecture will just use the concepts that we learned from the mesh analysis video in the last lecture, and we'll apply those on this problem, which is slightly different from the previous one. So in this whole circuit, I can clearly identify that there are a total of three meshes. There is this one mesh. I'll just mark it now. There is this one mesh. There is this second mesh, and there is this third mesh. So these are the three loops in the circuit. So I'll just use the same concept, and I'll start off by identifying the unknowns. There's the first current, the second current, and the third current. So there's the KVL on mesh 1. So I'll just start off from this point. I go clockwise and I encounter the negative sign first. Then I just go clockwise here too, and then I just come down here and I put this as the positive and this is a negative. So this is clearly an intersection between two meshes. So the Ohm's law would be the current in the mesh I am writing the equation for minus the other mesh in the intersection, which is I2. And then I can just move down here and there's this positive sign. So I'll just write plus 6, and then there's this 2 ohm resistor and I write plus 2, and this is clearly an intersection between mesh 1 and mesh 3. So this would be the current. So, and I come back at this node. So one thing to remember is you need to clearly identify the intersections between two meshes. This resistor was an intersection between mesh 1 and mesh 2, mesh 1 and mesh 2, and this 2 ohm resistor was an intersection between mesh 1 and mesh 3. So I used the corresponding currents. And now I'll just move on to the second mesh, and I'll start off from this point, and I encounter the 1 ohm resistor, which is an intersection between mesh 2 and mesh 1. So the mesh I am dealing with, I2, minus the other mesh in the intersection. So then I just move clockwise here and I come down here, and this is no intersection. The current is I2 in this resistor clearly, because this is not an intersection. This is just the periphery or the peripheral. And then I move down here to the 3 ohm resistor, which is an intersection between mesh 2 and mesh 3. So the mesh I am dealing with minus the other mesh in the intersection, and then I reach back at my starting node. So this is the KVL on mesh 2, and then I can just write the KVL for mesh 3 too, and I can just start off from this point. I encounter the 2 ohm resistor, this one, and intersection between mesh 3 and mesh 1, and then there's the 6 volt source, and I encounter the negative polarity first, so I write minus 6, and then I move here. I'm just moving clockwise, so plus 3 and intersection between mesh 3 and mesh 2, and then there's this 1 ohm resistor which is at the periphery, and this is not an intersection, and I can clearly see that the current passing through it is I3. So I just write plus 1 into I3 is equal to 0. And now right now I have three unknowns, I1, I2 and I3, and I have three equations. So I can just use linear algebra techniques to solve these three equations to find I1, I2 and I3. So this is how you solve problems using mesh analysis. So again, the things to remember is you need to look at the circuit very carefully and identify the meshes very correctly. And it is pretty simple, because meshes are just loops and you can clearly identify them. It is much more easier than identifying nodes. And the second thing to remember is the current when you are dealing with resistors at the intersection between two meshes. So this is what you need to remember. So the easy trick is just write the current of the mesh you are dealing with minus the other current in the intersection. So this is how you solve problems using mesh analysis, and I hope this makes things more clear.